In this video, I want to discuss integration by parts. First, let's start with a simple integral. Let's say we have the integral of e to the x dx. So let's think about how we can take the integral of this. Well, to take the integral, we think of a function that its derivative is the integrand. So in this case, the integral of e to the x would just be e to the x plus c. And again, the reason for that is because the derivative of e to the x is e to the x. Now let's think about another function. We have the integral of x, I will say 2x actually, 2x e to the x squared dx. So for this type of function, we can simply take the integral by using u substitution. So let's use u substitution and take the integral. So what we set u equal to in this case would be we would set, e to the x squared, and actually no, not e to the x squared. U has to be x squared, and once we take the derivative of u, du, we get 2x dx. And our du gives us this expression and the dx expression. So we can rewrite this integral as e to the u du. And we know, again, the integral of e to the u is just e to the u. So this is equal to e to the u plus c. And if we want, we can substitute back our value. We get e to the x squared plus c. So the integral of this is just e to the x squared plus c. Now, what if we had something like this? We had the integral of, let's say, x e to the 6x. Pause the video and think about how we can do this. I'm assuming you've paused the video and looked at this problem for a while. If you notice, first of all, without any integral technique, we cannot do this by hand. And a thing that will come to mind right away is u substitution. So if you try u substitution, potentially setting u equal to 6x, you notice that you still cannot integrate this because du would just be 6. So it wouldn't give you this expression plus this expression. So u substitution doesn't work here. And so we have to use something called parts, integrating by parts. And so in this video, this is where I wanted to introduce integration by parts. And before we do this problem, let me introduce the concept. So to get a little bit of intuition for it, we're going to start with fg and take the derivative of fg. We know fg is two functions being multiplied. So if we want to take the derivative of two functions being multiplied, we have to use the product rule. And the product rule is f prime g plus g prime f. Now, let's take the integral of both sides. Let's say we want the integral. Again, I'm doing this to show you why the integration by parts works. So if you take the integral of f g prime dx, and we take the integral of this side as well, so f prime g dx, or actually we'll put the dx at the end, f prime g plus g prime f dx, so the integral of fg prime dx, well, the integral of a derivative is just the function itself, right? So we can rewrite, and that's the fundamental theorem of calculus. So we can rewrite the left side as just fg, and the right side becomes, we can write the right side with separate integrals. We can say it's f prime g dx plus integral of g prime f dx. And that right there is just an integral theorem. If we have an integral of two expressions, we can just simply add the integral of each expression. Identity, not theorem, sorry. All right, now what we're going to do here is we're going to solve for, let's see, we're going to solve for this expression right here, f prime g dx. Actually, no, we're going to solve for this expression right here, and I'll show you why in a second. So to solve for that, we just simply subtract this whole integral to the left. So I'm going to rewrite this as g prime, actually let's write the f first, f g prime dx is equal to fg minus this integral, right? So minus f prime g dx. So maybe pause the video here and think about where I'm going with this. Again, it's difficult to see where I'm going with this at this point, but maybe give it a shot. All right, now I'm assuming you've paused the video and thought about it for a sec. Let's keep going. Now what I'm going to do is I'm going to do a substitution. You don't have to do this part, but I think this part helps because the the known formula for integration by parts, they use u and v. So let's just substitute some things. It makes things a little bit easier. So on the left side here, I'm gonna say u is equal to f. Again, it's f of x, right? But we want to simplify things here. And then v, so u and v look very similar, so we got to make sure to make them look different. V is g, right? And du, well, du is just f prime. And then dv, well, that's just g prime. So we have our substitutions. So let's substitute those values in. So we have the integral of f, so u, g prime dx, well, that's just dv, right? So the integral of u dv is equal to fg, so uv, minus the integral of f prime g dx. So let's think about this. This is going to be v du, right? F prime dx is du. So we get the integral of u dv is equal to uv minus the integral of v du. And in this case, one thing to note, and I'll show you why we're noting this in a second. Remember that the integral of dv is simply equal to v, right? This is something important to know. Now, let's remember this quote-unquote formula to apply it to the problem that we had. And once we apply it to the problem that we have, it will make much more sense. So let's write our problem. So the problem we had was, so right here we'll say example. We had the integral of, what was it, it was x e to the 6x. There we go. And we tried to do it with u substitution. We tried to do it with hand with other techniques, and it didn't work. So let's resort to our integration by parts. And okay, so let's look at this integral and see if we can notice anything similar with this expression and this integral that we have. So again, I want you to pause the video here and see if you can notice anything. Okay, so what we can say here is we can let x or e to the 6x equal to u. So we're going to choose one and let it equal to u. And you'll see why we're choosing one randomly in a second. It's actually, there's not much to it. You sort of have to guess one of the functions and let it equal to u. And then you let one of the functions equal to dv. So let me show you what I mean by that. So we'll say, let's just say u is equal to, let's say u is equal to x. And then we'll say that dv is equal to e to the 6x, right? And then dx. So we can rewrite this now as u dv, correct? Because we made those substitutions. We said that u is equal to x and dv is equal to e to the 6x dx. And we're able to do that. This is completely mathematically correct. Now we have this expression that looks exactly like this. So let's try to use our formula on the right to evaluate that integral. So our u dv, we have our values, so let's just substitute. Well, uv, what's uv? So this is the tricky part, and this is why I introduced this earlier. I said that v is equal to the integral of dv, right? So we need v at this point. We know that dv is equal to e to the 6x. What's the integral of dv? Well, the integral of dv is just integral of e to the 6x dx, and that's just, so let me write that in some turquoise color. That's just e to the 6x over 6, right? So this is actually just a v. And maybe pause the video there and see why that is. Okay, so now we have our u, dv, and v. I think we have all the values we need. So let's go ahead and, actually we don't have du, so let's just find du real quick, right? Because du pops up here. So du is equal to, well, du is just the derivative of x, so that's just 1. Okay, so I think we're good. Let's see if we can actually evaluate this now. So for the evaluation, I'm going to do it in, I'll do it in white. Okay, so we're going to use the formula on the right to actually evaluate this. So u times v, well, that's x times e to the 6x over 6. So that's just, I'll do it right here. So x e to the 6x over 6, right? I can't really multiply them. I just write them next to each other. So this is uv minus the integral of v du. So, okay, what's v? Well, v, we know that it's e to the 6x over 6. So let's write that here. E to the 6x over 6. And then du. And then du, so u is a function of x, so it's going to be the derivative of u, whatever that is, it's 1, and then dx, right? So let me just make that clear, actually. So this is 1 dx. So then this becomes times 1 dx, so it's just dx. Now, I think this is a doable integral. So this right here, this expression, we're actually done with. We don't have to do anything with this. But this integral, we still have to evaluate, so let's do that. So the integral of e to the 6x over 6, that's actually a very doable integral. And the integral of that, maybe pause the video here, see what that is. The integral of that would be e to the 6x over 36. Yeah, e to the 6x over 36. And then again, the way I think about that is I think of a function whose derivative is the integrand. And e to the 6x over 36, if you take the derivative, you get e to the 6x over 6. Okay, so we're almost done. I think actually we're done, but here, let me just rewrite this. X e to the 6x over 6 minus e to the 6x over 36. I think that's the integral of this. Now, how do we check that? We can check that by taking the derivative. Again, I repeat this a lot in this video, but the derivative of an integral is the integrand. So let's take the derivative and let's make sure we get this integrand right here. Hopefully we do, because if we don't, then we did something wrong and that'll be bad. All right, so first of all, for this first derivative, we need to do product rule, right? So first we have the derivative of x times e to the 6x over 6. So that's just e to the 6x over 6, because the derivative of x is just 1, plus the derivative of e to the 6x over 6 times x. So that's just x e to the 6x. And all I'm doing here is just taking derivative of functions. And then the derivative of this one. Well, that's just e to the 6x over e to the 6x times 6 over 36. So that's just e to the, wait, I think we forgot something here. Let's see. Oh, no, that's not, sorry. So it's e to the 6x over 6, right? If we simplify that, we get e to the 6x over 6. And this is actually very, very good because e to the 6x over 6 cancels with this e to the 6x over 6. Those two go away. And we're left with x e to the 6x. So our answer is correct. And again, the reason is that the derivative of this integral was the integrand. And that's how we checked our answer.